its new images of 3I Atlas. On 3I Atlas, a Manhattan-sized interstellar object.
In December 2025, something extraordinary happened. An interstellar visitor named 3I Atlas did something no comet should be able to do. Its anti-tail flipped direction. Not from our perspective, but physically reversed itself in space. Harvard astrophysicist Avi Loeb says this object contains something else that normal comets don't have. NASA captured it in X-rays, a signature most comets never produce. And now, scientists are connecting this mysterious behavior to sterile neutrinos, ghost particles that could rewrite physics. This isn't just another space rock passing through our solar system. This is an object that's forcing us to question what we think we know about the universe. Let me show you what has scientists so puzzled. When 3I Atlas passed closest to the Sun on October 27th, the Hubble Space Telescope captured something remarkable. This object has what astronomers call an anti-tail, a stream of material that points toward the Sun instead of away from it. Now, that's unusual enough on its own, but here's where it gets really interesting. Before perihelion, the closest approach to the Sun, the anti-tail pointed in one direction relative to the comet's motion. After perihelion, it had completely flipped. Professor Loeb emphasizes this wasn't a trick of perspective, the kind of optical illusion we sometimes see with solar system comets. The orientation actually reversed relative to the direction the object was traveling. Think about that for a moment. Normally, when sunlight hits dust particles coming off a comet, radiation pressure pushes those tiny grains away from the Sun. It's consistent, it's predictable. It follows the laws of physics we've understood for over a century. But 3I Atlas isn't playing by those rules. Loeb published 3 separate papers trying to explain what's happening. His conclusion? The anti-tail must contain something else beyond normal microscopic dust. He proposes 2 possibilities. First, fragments of evaporating ice that disappear before radiation pressure can turn them around. Second, much larger debris pieces that are simply too massive for solar forces to push around effectively. But here's what makes this truly fascinating. This object is showing 13 separate anomalies compared to the only 2 other interstellar visitors we've ever detected, 1I/Oumuamua and Borisov. 13 different ways it's behaving strangely, and the anti-tail is just one of them. Now let me tell you about something that happened that confirms we're dealing with something genuinely unusual. On December 3rd, the European Space Agency's XMM Newton Observatory pointed its instruments at 3I Atlas. They conducted observations for roughly 20 hours straight. And they found it, a clear X-ray emission from the comet. This matters because not all comets produce X-rays. In fact, the first 2 interstellar objects, Oumuamua and Borisov, were never detected in X-rays at all. When Japan's telescope looked at 3I Atlas earlier, they thought they might have detected something, but they weren't certain. XMM. Newton removed all doubt. This object is definitely glowing in X-rays. When gas escapes from a comet's nucleus, it slams into the solar wind, that constant stream of charged particles flowing out from the Sun. That collision produces X-rays. But here's the intriguing part. The intensity and characteristics of those X-rays can tell us about the comet's composition. And if 3I Atlas is made of different materials than comets from our solar system, those X-rays could reveal it. This brings us to one of the most controversial aspects of this whole story. And to understand it, we need to talk about what happened in the scientific community recently. 2 major physics experiments just concluded. They cost a combined $90 million. Both were searching for something called sterile neutrinos, hypothetical ghost particles that don't interact with normal matter. These experiments, Micro Boone and Katrine, were following up on earlier anomalies that suggested these particles might exist. After years of work and all that money, both experiments came up empty. Sterile neutrinos, at least the kind they were looking for, don't appear to exist. Now here's where Avi Loeb makes a pointed observation. The scientific community had no problem spending $90 million chasing these exotic particles based on anomalous data. Nobody called it nonsense on stilts. Nobody dismissed the researchers as fringe scientists. Even though the experiments ultimately found nothing, the pursuit was considered legitimate science. But when Loeb suggests that the anomalies of 3I Atlas deserve serious investigation, including the possibility of technological origins, he faces immediate pushback. One editor, Chris Lintott, demanded Loeb remove a sentence from his paper that suggested if 3I Atlas is a large, solid object, its trajectory toward the inner solar system might indicate technological design. Loeb's point is simple but powerful. Why is it acceptable to spend massive resources investigating exotic physics based on anomalies, but unacceptable to seriously investigate anomalies in interstellar objects? Both involve unexplained data. Both could revolutionize our understanding. The difference seems to be purely about which anomalies we're culturally comfortable exploring. And here's the thing. Loeb isn't saying 3I Atlas is definitely artificial. He's saying the anomalies are significant enough that we shouldn't dismiss any explanation before examining the evidence. That's just good science. Let me show you another one of those 13 anomalies. When 3I Atlas first appeared, it had a reddish color. That's what astronomers observed before it disappeared behind the sun for several weeks. But when it emerged and the Gemini North Telescope captured new images on November 26th, something had changed. The comet now had a distinct green tinge. This green color comes from diatomic carbon, C2, a molecule made of two carbon atoms bonded together. It's highly reactive, and when it gets excited by solar radiation, it emits light at green wavelengths. We've seen this before in other comets. 3 comets earlier in 2025 showed similar green glows, though one of them later turned golden. But here's what's interesting. The color change indicates the comet's composition or activity level changed as it passed through the inner solar system. Combined with the anti-tail behavior and the X-ray emissions, we're building a picture of an object that's far more dynamic and complex than a simple icy rock. On December 19th, 3I Atlas will make its closest approach to Earth, passing at a distance of about 168 million miles. That's 270 million kilometers. It's completely safe, no danger whatsoever. But it's close enough that telescopes around the world will have their best opportunity to study this object in detail. The Gemini North Telescope has already been observing it as part of a program called Shadow the Scientists, where members of the public work alongside professional astronomers on real scientific experiments. Bryce Boland, the program lead, said sharing this observing experience gives the public a front-row view of this interstellar visitor. And this is where the exotic particle physics connection becomes more than just speculation. If 3I Atlas is made of materials we don't normally see in solar system comets, if it contains exotic ices like nitrogen or hydrogen in unusual forms, those X-ray observations could reveal it. Scientists had suspected that Oumuamua might be made of such exotic materials, but we never got close enough or detected it in the right wavelengths to prove it. Here's what we're really looking at. 3I Atlas represents our best chance yet to understand what comets from other star systems are actually made of. We missed our opportunity with Oumuamua. We got better data on Borisov, but it appeared fairly normal. Now we have an object showing multiple anomalies, detected in X-rays with unusual anti-tail behavior, and we're watching it in real time with some of the most powerful telescopes ever built. The connection to exotic particle physics isn't just about sterile neutrinos. It's about the fundamental question of whether the building blocks of planetary systems around other stars are the same as ours. If they're not, if interstellar space can forge materials and structures we don't see in our own cosmic neighborhood, that changes everything we think we know about planet formation, the distribution of elements in the galaxy, and potentially even the conditions necessary for life. Professor Loeb has now written 11 papers on 3I Atlas. He's not doing this because he's convinced it's alien technology. He's doing it because the scientific method demands that we investigate anomalies thoroughly, without prejudice about what the answer might be. The anti-tail that flipped direction tells us something about the object's composition or structure that we don't yet understand. The X-ray emissions tell us about how it interacts with the solar wind in ways that might be unique to interstellar objects. The color change tells us about chemical processes happening on its surface as it heats up and cools down. Every one of these observations is a piece of data, and data doesn't care about our preconceptions, it just is. Our job as curious humans is to look at that data honestly and follow it wherever it leads. The good news is that 3I Atlas won't be the last interstellar visitor we study in detail. The Vera C. Rubin Observatory just came online and began its legacy survey of space and time. This telescope is specifically designed to scan the entire southern sky repeatedly, detecting anything that moves, changes, or appears. It's expected to discover millions of new asteroids in just its first 2 years of operation. More importantly, it will dramatically increase our detection rate for interstellar objects. What was once a rare, lucky discovery will become routine science. We'll have more opportunities to study these visitors, to compare them, to understand what's normal and what's truly anomalous. 3i Atlas is teaching us that the universe is more complex and surprising than we imagined. Its anti-tail shouldn't flip, its X-ray signature shouldn't be so clear, its behavior challenges our models, and that's exactly what good science needs. Objects that don't fit our expectations, that force us to look deeper, think harder, and remain open to possibilities we hadn't considered. Whether it's exotic ices, unusual debris, or something we haven't even theorized yet, 3i Atlas is showing us that interstellar space holds secrets we're only beginning to uncover. And that's what makes this moment in astronomy so exciting. We're not just watching a comet pass by, we're witnessing the birth of a new era and understanding our place in the galaxy. If you found this fascinating, do me a favor. Hit that like button to help YouTube show this video to more space enthusiasts like yourself. Subscribe if you want to stay updated on 3i Atlas and other cosmic mysteries as they unfold. And here's something special. Leave a comment below telling me what you think about Avi Loeb's argument. Should we be investigating these anomalies more seriously? Or is the scientific community right to be skeptical? I will read every comment, and I'd love to hear your perspective. And if you know someone who'd be blown away by this story, share this video with them. Let's spread the word about what might be the most important interstellar visitor we've ever encountered.